Hi, it's Gadget UK here again. As you can see, this time I'm looking at a 2-slot, and this is the only MVS variant that I've not looked at in my collection. Got one in my collection yet. So yeah, I've been after a 2-slot for a while. I wanted one of the ones with the Pro chipset, and I think that's what this is. I'm not 100% sure, but I think so. There's little bits of corrosion on top, not a lot. It also came with the wiring loom as well, with the Jama connected there. It's very interesting. I've never seen anybody send me the entire wiring loom with one of these before. So quick look on the underside first of all. You can see it looks pristine. It's super clean. So I suspect what's happened with this, the common thing is the battery's leaking, the battery leaks. You can just about see it down there. Yeah, you can just about see it down there. I see some corrosion, not masses, but still, I think that's perhaps what the cause is going to be. So we'll get the screws off from around the sides and then have a look at the board. Yeah, so got the shielded off, and now this is described as having graphical issues, and this is the ZMC2 here, which I think demultiplexes some of the graphics stuff, so it's no surprise that we've got graphics issues if you've got that much damage around there. You've got some leakage there as well, can you see that? Corrosion around that RAM. But in the first case, I think I will start by just clean up with cotton buds and IPA, but I think I'll remove the ZMC2 actually, just so we can inspect and clean up the pads and things like that. I mean, there's a little bit of corrosion around the components around here for the charge circuit, but not masses. We've got some trace damage there, can you see that? So yeah, and they're quite thin traces actually on this board. I'm surprised, these look even finer than the 4-slot. They're super fine on this one. So I've stuck the 4 feet back on just for the moment because it means I can sit it on the carpet here, and I'm not actually going to be making connection anywhere near. And I'm just going to snip the battery off at this stage. I will remove the contacts cleanly from underneath later, but I just want it off there, out of the way while I'm working on it. And as I say, I'm just going to start by cleaning up with cotton buds and IPA, and then I'll get the fiberglass pen onto some of these traces and connections here, and I'm just going to inspect and just perhaps measure some of them just to see where the breaks are. Hopefully there's not too many. Hopefully we've not got a situation here where I'm going to be putting 15, 20, 30 wires on here to deal with this. I suspect these traces here are going to be the main part of the issue actually. It's pretty dirty, as you can see. Can't get much closer than that at the moment, but just cleaning up the pins here with the fiberglass pen and these traces here. It's going to expose them, but we can tin over them afterwards. In fact, it's coming off super easy. You can see copper there. Normally it would take a lot more friction than that. It might just be this trace here and some of the ones down this side that are the problem. I'm just using some IPA here. I've gone over this with some white vinegar, actually, this whole area here. But what I'm trying to do here is just remove the corrosion off the tops of these tracks, which I've just done with the fiberglass pen. And then I'm going to get some flux on there, and I'm going to tin all that up actually. I might need to clean it a little bit further first with the fiberglass pen before I start to try and tin it up. But the plan is, like I said, try and tin that whole area, and then at least I can start to see what actually needs a wire somewhere and what doesn't. You can see it's super messy. It's making a right mess. I don't really like using fiberglass pens in such a large area like that, but there is so much corrosion there. There's no choice. You can't just leave it. It's got to be. You've got to remove the corrosion. So we've got a trace here that comes up here that I think that's the main one that might be causing the problem with this actually. Let's see if I can point. Yeah, and let's see if you can see, it comes up here and then it's dark green here. I think that one might be broken, but one or two of these may be broken, and some of these wires you can't see from a distance, so I'll give you a real close up in a minute. But yeah, we might have some damage around there as well, but yeah, we can certainly tell a lot better once I've fluxed and tinned that whole area, I think. Right, we're on Super Macro, so you can see the ground and VCC connections here, are going to be affected to this. I need to make sure we've got those before I power this up. because say for instance you were missing the 5 volts of the ground, you could get a latch up fault here and we could kill this completely. I mean, it may well be already damaged that way by the person who owned this previously. You know, they'll have powered this up to see whether it works or not, and obviously it doesn't. Yeah, this is the trace I suspect might be causing the main problem, but you know, we've got some issues here. You know, we could have breaks in a number of these as well. But you can see, you know, just using the fiberglass pen there, I've just exposed these, done the same here. Again, we could have some bad connections to these wires. So I'll continue cleaning up here, like I say, then I'm going to flux and tin it all up, and I'm going to do some connectivity measurements at that point. What I'll probably end up doing, as I said right at the start here, is remove this, but I want to work out what's broken first if I can, and then maybe take this off later, clean it all up, put it back on. There are some other areas here around the board. You can see here, got some corrosion here, but it looks like it's just landed there. It doesn't look like it's interfering with anything. And the RAM over here, again, that kind of looks like rust more than anything. But again, we might need to remove and clean up some of these. It's more cosmetic though, I think. It's mainly this area, and then obviously around the battery here, and this chip probably will have to come off as well. You can see some corrosion around the HC32 there, but everything else around there seems okay actually. A bit of corrosion around there maybe, I'm not sure. So our VCC and ground connections are okay on that chip, I've checked that. So I figure let's just give it a try now, see what's happening. So I'll switch it on. Wow. Yeah, it's actually booted. So, okay, I'm going to try a cart at this stage. I know there's probably going to be some graphical issues. I've cleaned up those traces as best as I can at the moment, and there's those two that I showed you that look a bit dark, but I've cleaned those up. I'm not entirely sure whether there's a break there. So you never know, it might just work. We might just have to just clean this up. So, I'll switch it off. Let's get a cart on the other MVS boards. Let's just see what happens. Yeah, so we've definitely got some graphical issue going on there. I don't know if you saw that, it sort of came up and then went away. I mean, that could be a dirty slot. And yeah, no graphics at all, is there? I'm not hearing any sound either, strangely enough. That might be the volume. Let me just... Yeah, that was just the volume. So we do have sound. Let's just try the other slot. I mean, it's crazy, but I'm thinking actually the corrosion might not be what's actually wrong with this. It could be the VRAM, but then wouldn't it report that at the beginning? Yeah, I think it would. I think the standard BIOS would detect a VRAM fault, I'm pretty sure. I think that's one of the things it tests. Yeah, it's curious how we kind of had something originally. I don't really remember. When it first came up, I sort of saw the Neo Geo logo just briefly, and then it went off. At this point here. So, okay. Let's try the Diagnostics BIOS on it. So just carefully lever this out here. Should be using a dip extractor really, but we should be alright getting it out this way. There we go. Put that onto the power supply there. And where's pin 1? Yeah, pin 1's that side. We'll just get the Diagnostics ROM in. And I've got the controller plugged into port 1. Yeah, all tests passed. So that gives us a good level of confidence that the backbone of the system's okay. There's no VRAM issues or anything like that. It's all going to be about this ZMC2 connections, I think. We can reset it with select and start. Let's just hold ABC down and then hang on, do a select and start. Should take us into that menu, get a calendar. Yep, that's okay. Turn to menu, colour bars, looks fine. Controller test. Yep, that's fine. WRAM and backup RAM, it does both, I think. Yep, that's fine. I mean, we know this anyway because it's telling us that on the, the fact it's saying all tests passed, but nevertheless, it's a nice test to do them individually. Yeah, okay, well, I'll continue next by measuring some connectivity around the ZMC2, I think. Well, I joined up a missing connection here, which I'm going to redo in a minute because I think we're going to remove this. And then we got a calendar error for a few minutes actually, and I think that's going to be related to the corrosion here. I think something there's failed, the tracer's burnt out or something, I think. So we've got a second fault as a result of testing. This is one of the things really, it's probably better to clean up and fix everything and then test it for a prolonged period of time. I was only had it powered up for a minute, but nevertheless, you know, I sort of saw the Neo Geo thing and then it disappeared. And I had that a few times where the Neo Geo bit sort of came up and then disappeared. And then I think on the third power on power off I got a calendar error, so yeah, something around here, the HC32 I think. So for the moment I'm testing with the unibars, so I just want to show you. I thought, I wonder if it's some of the deposits here. I've cleaned this up, but yeah, you've got deposits between the pins. But now, I'm not sure if I'm going to capture this. One of the pins here is loose. Let's see if I can find which one it is, hang on. Yeah, it's this bottom one. Just watch. See that? You see it moving? It's come loose. The solder's detached, so I'm going to flux up, clean up again first of all, and then flux up this side and then reflow that whole side. Well, we're making steady but slow progress. You can see we've got the Neo Geo logo back, but a minute ago it just disappeared. I'm not sure why. You know, the sprites disappeared, like we've got sprites. Oh, then it went. So, yeah, still a bad connection or something somewhere. Wobbling the cart doesn't make a difference. But you can't really easily reflow these, you know, when they're in this state. You know, it took me a lot of effort to reflow that side there to make some progress to get the logo back up, but it's intermittent, so it stays up for a little bit and then it disappears, graphics go again. And only when you power cycle it does it come back. So, I mean, that could indicate a problem somewhere else on the board. It could be barking up the wrong tree, but this needs to come off here, I think, anyway. Just part of the clean-up work, really. I mean, if this is faulty, I think I've got a spare ZMC or two on some of the spare boards that I bought off my repairman, actually. Interestingly enough, I've got a D0 on this board, which I'll show you in a minute. So we could borrow the D0 off here, I might do that. Let's have a look at those 1F boards again. I think it's starting to come off now because you can hear it sort of squeaking. Yeah, I'm not pressing very hard. It might look like it, but I'm not. And you've got to be even more careful when you're removing it from corroded PCB traces like this, you know, corroded pads. But yeah, it was a good idea removing it. You can see just how dirty. You can see the blackness around here on the underside. So cleaning up with cotton buds really gently because we've got lots of solder that could easily stick to the cotton bud and pull the whole pad and everything off with it at this stage. And I've got some flux on here and we'll try and mop up all this corroded, crusty solder. The nice thing is, and I'm pleasantly surprised, there's not tons and tons of tracers underneath going to wires and things like that, because I was thinking that maybe we could have some damage there, but I don't know if you can just see the chip here, it's just kind of offshot a little bit. You see some of the pins, like, this has got a funny grey colour. They've detached from the solder and then kind of oxidised and got corroded. And I think this is why it's behaving as it was even after a reflow. I think, you know, after leaving this in some vinegar for 20 minutes, then cleaning it up with the wire brush, not the wire brush, the fiberglass pen, super gently, flux this whole area, refits it. I think it might work. I think that's all it is. I think we're just getting a bad connection on some of the pins. You know, I found two. You saw the one down here that was floating and the one here was floating. It stands to reason one or two of the other pins were making a bad connection as well. It's not just going to be those corner points. So there you go. You can see I've been mopping up the desolder braid and flux. This side here, super easy. No problems at all. Solder came straight off. Down here, super easy. Struggle a little bit on the last pins on this corner here, but you can see it looks alright. But do you see the difference? Look at these here. Can you see how black they are on this side here? The corrosion has indeed got underneath the pins, lifted them up, makes you think they're connected, and actually they're not. You've got like a resistive connection. And because obviously it's conductive, the corrosion, you get connections to the next, nearby pads that are next to it and stuff. And it's the same up here. You can see how black those are there. There is a ton of corrosion around those pins. So I'll get all the flux off super carefully like this. We've got loads of it in the middle here that's stuck on there in a solid mass. And then I'll go over with the fiberglass pen very, very, very carefully. And my scratchy tool, it's like a pinpoint just on the surface of the pads there to try and get that contamination off them. Then I'll get some more flux on and use the desolder braid again. Got to be careful with the cotton bud at this stage, because like I say, bits of solder are still going to be on there. You've got to pull them or snag and you'll be tearing things off the PCB. As things stand, we haven't lost a pad yet. We might lose one before I'm finished, but hopefully not. So as I say, using a tool like this, I'll see if I can demonstrate, you can scratch that black stuff off the surface there. Yeah, it's hard to do this and film it, but trust me, you can with a pin, something very fine. The problem with the fiberglass pen, it doesn't always work very well, but we'll give it a try. And again, you've got to be super careful because we've got bits of solder on. Yeah, it's coming off a little bit, but that tool I usually use makes the biggest difference really with something like this. There we go, that's after cleaning up, that's looking pretty good. So I'll clean up the chip now and get the chip back on there. I'll finally, finish off by tinning some of the traces and things. We'll remove this cap and clean up the, not the wires, but the connections and things next to that. But I want to do that later. The main focus is try and get this back on, just see if the graphics are reliable. So you're probably not going to be able to see this, but the only real way to get the corrosion off the bottom of the pins where they were affected is with a very, very fine piece of sandpaper. Before I did that, obviously it's been soaked in some vinegar for 20 minutes, and then I've cleaned it off with IPA and a toothbrush. But it still needs more cleaning. You can see bits of flux and stuff between the pins and on the underside. So the next step now is I'm going to get some flux on some desolder braid and just very gently drag it across the top on all four sides, and just make sure that the pins do look nice and clean after doing that. So our chip is all cleaned up and in position. I'm just going to tack diagonal opposite corners and then get some flux on and drag solder around. I'm not going to show you this, I've shown it in loads of the other MVS videos. If you look at the 10 Neo Geo videos there, there's probably 2 or 3 videos there where I've showed drag soldering and moving chips like this, soldering chips like this size back on and stuff. So where are we? Well, so the bad news is my logic probe has died. Luckily I've got this that came from one of my viewers actually. Really nice guy, Colin McKay. It's a HP, as you can see, 545 logic probe. So yeah, I've been using that to try and work out what's going on. Around the ZMC2 here, I think connections down here and around the side are C connections. So they go to the cartridge, the C interface on the bottom board, is it? The one with the character ROMs, where the graphic code comes from. Now, there isn't a direct connection there, sorry, I'm confusing things here. I think it comes through these 257s. Yep, I could be wrong. I think it comes via these 257s. So, I'm seeing pulsing, the point I'm trying to make here is on the C pins, C, I don't know, C1, C2, C3, etc. I see pulsing, actually, which kind of indicates to me that the code, the program, not program, but the data is coming through these 257s without issue. So it would seem to suggest either a fault with this or a fault somewhere else. And it's doing exactly what it was doing after I, fixed that first trace there. I'll show you, I'll point you to the screen now and you'll see that it works for a second or two. You see the Neo Geo logo come up, hopefully. Oh, it's not doing it now. It's intermittent. This is the problem. It's intermittent. But when it's cold, it's got more likeliness of, there you go, of working. Watch it disappear, watch. Hang on. Yeah, it's got more, look, there you go. It sort of disintegrates out and disappears, and that's it. And when it's been warmed up, it's super, super, super hard to get it to do it at all again. But at the point where we measure around at that point after the graphics have gone, I still see data coming in on the C connections. It's pulsing away there, so I would expect that that should be passing through that chip. It should be going out on, I think, the G connections. I think there's 8 different G connections there. I think it basically passes a strip of, is it 8 pixels? I think it is, something like that. So I think I'm going to swap the ZMC2. I've got the spare one I took off that junk MV1A board in a previous video. And in fact, I think I can demonstrate this actually, just measuring one of those G connections there. Now, the question is whether I can get the graphics to come on or not. I appreciate you can't see this, but I'll tell you if it's on. Right, hang on. Right, so you see pulsing, hang on. Right, it's on. See it pulsing, it's on, still on, still on. The screen's on black, hang on. It's gone, there's no graphics, and it's not pulsing. So this to me says actually this is not working. Actually, yeah, there's nothing you see now. Black screen, no graphics, not pulsing. So I think it's this. That's a nice, easy way to test that. You know, probe your C connections, see if you see pulsing. Probe your G connections. Like in my case here, like I said, the pulse up until the image distorts and disappears on the screen, then you just see nothing. You know, nothing at all, or low, or whatever. So yeah, I'm going to remove that next. There we go, chip removed a second time. Got some fresh flux here because my flux has just run out. And we've got the donor ZMC here. I just need to drag the desolder braid on the underside of that just to make sure it's flat, because there's some bits of solder there. And then we'll have a go at fitting that. I'll perhaps film this time around. Pin 1 is up here. You can just about see there's a little notch on the package there, and pin 1 marking is there on the board. The trick is to touch the pad, not the pin, and just flow a crazy amount of solder onto it. And the same over here, pin 24. Just try and solder, there we go, that way. Press it down, flow it, hold it down, reflow it, then release. So I'll just inspect that, make sure that's totally straight, which it is. You can see OK actually written on that upside down, just because, like I said, that came off one of those MV1As. It was the one we used for spares. There was one board out of the 7, I think. I do hope this fixes it, because the other possibility, you know, we saw there was no data being passed through that chip. That's, you know, that's for certain. But what we don't know for 100% certain is whether some sort of control signal, maybe from one of the Pro chips on here, is missing. But what I do know is the connectivity looks super good actually on the board. So I don't think we were in a situation where we had a bad, you know, corroded wire or corroded connection. All these traces here are really good. There's not an issue from that perspective. Now we can clean off all the extra solder and stuff there in a minute. The first thing I want to do really is just get some solder onto each of these pins. So yeah, like big lumps like that, you're going to get them on a chip of this pitch, even with really super good quality flux. But we can clean that up afterwards, and then I'll clean it up off camera and show you perhaps before we test it. Yeah, I can't get the iron at the right angle because of the camera. There were quite a few giant blobs there. Right, I'll just reflow that. So let's give that a try. Fingers and toes crossed. Well, that's looking good. But it was fading out somewhere around here. Oh yes, I think I've fixed it. Yeah, it's interesting because you could think, well, would it be that, you know, you could be led down the path of thinking the ZMC was alright, because if you're getting some graphics, why would you then not get graphics? And how would that chip have failed? You know, you could think, well, the corrosion, if it made the chip fail, it would just not work at all. You know, i.e. a completely damaged connection. Let me just turn the volume down a little bit. But the thing you've got to remember, when you get corrosion like that, it's conductive. So, you know, a number of pins can be shorted out on there for a period of time whilst someone's testing it, trying to understand what's wrong with it. You know, is it bad connections on the Jama edge, etc. You know, trying it a number of times and stuff, and it could be left powered on that way. It could even actually have been left on, powered up in a cab, you know, 24/7, and at some point it starts to fail, and you've got some conductivity there from the, you know, alkaline. Various things can short out. So yeah, some gates, internal, you know, connections and transistors and things internal to that chip can fail, and they can fail in such a way that the kind of they're not completely dead. And I think that's what we had there. We've got one transistor that's sort of switching until it warms up a little bit and then it gives up the ghost. And that was why it was kind of fading out. But I'm glad I didn't remove the chip to start with, in the sense that, I cleaned it all up, we didn't power it up, we cleaned it all up, we fixed the damage trace, then we powered it up and saw what was going on. And I managed to get the graphics back, but they would then fading out, the logo faded out, and then it would remain off until maybe it was, powered off. Because had I not seen that, you see, I'd be wondering what the fault was. The fact I kind of ruled out all the connectivity. It had to be either this or the thing this was feeding, perhaps, or maybe even control signals for the ZMC2. There's going to be some other pins and things around there that dictate, when data comes across and how data comes across out of it. So it could have been something like that, but I knew the connectivity was good, so kind of logic says really that it was going to be the ZMC2. Sweet. So the only other thing now is that calendar error, because at one point I did get a calendar error. Now that might be related to the HC32 that's nearby, although looking at the board, I'll show you in a minute, the HC32 is way on the other side of the board, away from the D4990, whatever it is, the real-time clock chip. But then again, it could still be used the same way. We could still have one signal coming out the that OR gate there that's used by the chip on the other side of the board. That's not out of the realms of possibility. I think I'll just put the diagnostics back in. We'll just see what's going on with the calendar. Do we still have a calendar fault? So before I test with the diagnostics, we'll just we'll test both the slots. Let's just see if it toggles the track modes here between the two slots and whether we got sound. Let's turn it up a tiny little bit. Yeah, that's not too bad. Yeah, the other points that I was trying to make there about the order in which I did things is because I determined we had that graphical fade in, fade out problem right from the start. Before I removed the chip, when I sanded the pins down there to try and get corrosion off, because that could have contributed to some ESD damage. I know that wasn't the cause because it was doing the same thing before I did that, before we reseated it. So that should go into the fight now, I think, and then maybe the high score table, and then hopefully it'll cycle to the next cart. But I mean, that seems to be working fine as well, so yeah, got a good level of confidence. This board is probably 100% now. I kind of feel a bit better about the old, there's 2 or 3 boards that I've got as spares here now as well. I've got 2 where I've got D0s that I haven't got, I need D0s for, and a lot of corrosion damage. And then I've got that MV1A, which is the one that I've taken the ZMC for this from. But I'll show you that board in a minute. I cleaned it up afterwards. That board could be repurposed, but there's just so much missing from it. But I don't feel bad about that now because it fixed 6 of the other MV1A and /AX boards in previous videos there for Mike Pearman, and it's fixed this. And I think one of the chips went onto my 1B as well, so it's fixed that. It's fixed 6, 7, 8 boards. One board has given its life to fix 8 boards so far, and there's still other stuff on it which could fix other boards. So that makes me feel quite positive. But anyway, you can see it's cycled there, no problems at all. Graphics are alright, sounds are alright. So just cleaning up, I think one thing I might do, I'm not sure I like this big wire. I mean, obviously I can tie the wire, but I don't want a wire going all the way across the board there. So I think what I'm going to do is scratch off the solder on the trace that's broken here, because it's broken as it joins the pin. And I'm going to use a piece of coil wire, just because you won't see it. It'll be so small you won't even see it. There we go, looking a lot cleaner now. I've done the wire fix there, which I'll show you in a sec. Obviously I need to clean around the surrounding area. These components here are going to have to come off. Corrosion damage? What corrosion damage? Obviously that cap needs to come off yet, but can you see that? Can you see the wire I've added there? Let me just see if I can point. Yeah, it's there. You can hardly see it. There is a wire, trust me, from here up to there, because the break was like here somewhere. But as you can see, that's looking sweet there. Tinned all those traces up. The vias could do with a little bit of work around here, but and there's perhaps a little bit more copper. Still needs, get some more flux on here and tin these up. But yeah, I think you'll agree that looks pretty good actually. Yeah, I'll get that cap off next, I think. So I think the next one we'll do is just give the board a general clean. The larger areas I'll go over with paper towel actually in a minute, but I'll just get in between the chips and things here Obviously need to finish off the components around the ZMC, you know, particularly the battery area here in that cap. I'll do those last actually. I'll leave that area of the board until I've finished cleaning up all the rest of it. So part way through the cleaning up, you can see the top end of the board here. You know, I've cleaned all around there, and the right hand side you can't quite see there. I need to finish doing the bottom half of the board. Yeah, I've done some of the middle part here, but yeah, there's still lots of areas to clean up, including all this area here. So the next thing I'm going to do is remove this chip. This one's okay, but there are some green pins around that HC32 there. So I'll remove that, clean up around this area, remove these components. I'll do them one at a time. And I've shown this sort of stuff before. I did it on the 6th slot, I think, where, you know, it's a case of desolder the component, clean up the pads, make sure it's super clean, clean up the legs on the component and refit it. It really is that simple. While I'm there, I'll swap that cap. It may as well. There's no point in taking it off and putting it back on, because ultimately I would recap a board like this anyway. I mean, there's not a massive amount of caps, well, there is down here on the audio section, but and it's working fine, it sounds fine. So at this point in time, I'm not going to recap it, but I will do at some point in future. Now the other thing I'm going to do that does not need doing, but I want to do it, is to remove the DAC here, the audio DAC, the YM3016D. And I also want to remove the 4990. The reason being, I'm going to put sockets on for those because I have some spare chips that I ordered. I think I got some 4990s from AliExpress, and then I think later I got some DACs from AliExpress as well. So I have some of those that I just not got around to testing, and I want to determine whether they're any good or not, and I've not got any sockets on any of my other boards for those two chips. So yeah, it's not really a big problem. It just means it's super easy to swap out in future anyway. And earlier on, I didn't capture it, I don't think, but I did get a calendar error when I first switched this on, which is this chip here anyway. So it's advantageous to have those socketed, I think, moving forward. So I removed all the solder from the underside, and yeah, I'm freeing them up this way. And I'll tell you why, because the traces that go to the pads and the pad size on these are so super small. It is very, very easy to damage pads when moving these chips. Now you can get them off without doing it, because I've done it myself. I've done it just using the standard solder sucker, 15 watt iron, and then manually remove them, and I've not damaged anything in the past. But just for time reasons and, like I say, safety, just trying to avoid any damage whatsoever, heating from this side to free it up is the best thing to do once you've desoldered from the underside. There we go. So again, just use hot air to remove that one, and it's a good job I did. Just look, can you see all the greenness underneath and the green here? Lots of corrosion. And there's the third one removed as well. So I'll just clean up those three areas and get 3 sockets on. So whilst the desoldering station's heating up, I'll clean around this one now. I've done the other two. We'll clean all that gunk off there. You can see that thick green sludge. This area has been cleaned with vinegar previously, but obviously, you know, it doesn't get right under there and right around and stuff. And then I'm going to need to use the fiberglass pen now and my scratchy tool just to gently remove any contamination off the tops of the pins. And we'll probably need to expose the traces that run under there and tin those up, just like I did with the, you know, the damaged ones up here, because they're going to be ultimately, you know, they will corrode and break. So there you go, that's before I tinned it up, but you can see I've exposed the bits of copper here, I've cleaned up all the bits of corrosion off there. That's not looking too bad. I just need to deal with those, tinning those traces, and obviously the one that goes right up here as well, because all the surface coatings just come off it with the corrosion, and a bit down here on this one as well. So I've got a bit of solder on the iron there, and I'm just going to tin up the end of the braid, and we're just going to drag it over the trace there. Yeah, you can see that one's, well, you might not be able to see, it's kind of gone silvery. There you go, so you can see we tinned this trace up here, this one, this one, this one, and cleaned up these here as well. I'll just clean that a little bit more actually, but then I'm going to stick the socket on. Bear in mind, these are the components that are going to come off now as well, so I'm going to go further afield and just do the same thing around, you know, the area up there. Down here, it's not so bad. I'll perhaps just clean up the connections here and we'll get some more vinegar around there just to make sure there's nothing going on there. But this is just all dirt here. It's primarily this area up here, and I need to obviously remove the contacts from there as well, and all the glue. Before I forget, don't just go off visual inspection. Actually test the connectivity here on the connections that you can see, just to make sure that you've not got any breaks. Let's see if we can get that on there. Super fine, that trace. Yeah, I want to test it as far as up there. Should go to the transistor actually. Yeah, it does. Yeah, just to make sure you've got no breaks, because the last thing you want is to miss one of these. Not sure where that trace goes. It goes under here, probably to a wire. Right, it goes over there, so that's okay. I'll clean all that black sponge off in a minute. You know, using IPA to get it to peel off, sometimes that works, but more often than not you'll find these things just disintegrate. So again, same old thing I've shown before, wire brush, and then use the fiberglass pen. But on the tops here, where they're particularly corroded, I will use the wire brush to start with. And there we go, after 30 seconds of work there, can you see? That looks good as new. Cleaned up with the vinegar as well, and the toothbrush. But yeah, I'll stick that back in now. The worst that can happen is that fails at some point and you just swap it out because it's socketed. So one thing that's always worth doing when you're working on a board like this and you're doing this sort of thing is test it as you go along. So we've got that one socketed up now, that one's socketed up, and that one's socketed up, so I've got to test it, make sure it's still working. So one other quick tip for you, if you've got one of these, like I have, a cheap one, you'll note that what happens is eventually, look, with a bit of pressure, it slips through the back there, and you end up with like a little bit like that, and you think you're out, and you're not. You take it out, it's like that. It's super annoying. Fold up kitchen roll and stuff it down there, because you only need a certain amount in there, and then you'll get to the point where when you push this in, it can't go back because you've filled the cavity. Really, those things shouldn't have such an extended area inside, but yeah, as you can see, we've got a bit of distance there now, and I could still put a bit more in there actually, because it's still not going back. As you can see, it's still going back a little bit, so let's stick a little bit more and just rip some up like that, twist it and shove it in there. It seems crazy, but it's like I say, these things are designed, you know, they're manufactured very, very cheaply. Yeah, look at that now. We've got a good distance on that. Yeah, look at all that. It was right down, I was having to swap it out. There we go, it should have been a while. So we're getting there, cleaned up all the traces around here. I've done these 3 resistors there. I'm just doing this diode. I'll do these 3 components there, and then I'll do these 2 transistors last, I think. And as normal, I never do things in the order I say I'm going to do them. I've done those 2 transistors, so those were really dirty, the legs actually. It took a bit more work to clean up than some of the other components, so I've just took off the final resistor, diode, and the cap here. I'll put a new cap on, get those on, clean that whole area up, and I'll show you what it's like. I need to clean the underside up yet, and obviously clean up the top side of the board. You can see the contrast here. See how shiny it is now and how dull it is here. So I've finished the top side, I'll show you in a minute. I'm just trying to remove the remainder of this stuff, and if I ever said it was easy, I apologise in previous videos. Leaking IPA under there before you peel it off, yeah, you can get the majority of it off, as you can see here, but bits of it come off, and there's no easy way. You know, heat doesn't help, IPA doesn't really help. It just disintegrates, you know, and it's all sticky, and it's just a mess. It just takes ages getting this stuff off. I hate it. And the same can be said about the hot glue. The hot glue that holds the battery on, it was a tip that Voltar pointed out actually to me, and I mentioned it a number of videos back, and I've used it a fair bit, and it works majority of the time. You don't have a problem. But on these, it's this kind of glue that, I don't know whether it's the battery acid, the alkaline has affected it or whatever, but you remove most of it comes off, and you get these bits still on the board, and it doesn't come off. It doesn't matter how much IPA you use, it doesn't matter what you use, you have to use friction. You've got to rub it and rub it and rub it, you know, and try and scratch it with your nail without damaging the PCB. It's super hard to remove the remnants of it, just the little bits. You get like streaks of it that just seem embedded in the board. they're really hard to get off, but anyway, I'll show you in a minute. I managed to get it off. It just took an awful lot of time, like 15 minutes just to remove a bit of hot glue. I'm going to test those chips I've got, the DACs and the 4990s. So unlike the 4 slot I've got coming up, you'll see the shell on that one's a nightmare. This just needs a little bit of sanding just where the rust particles are. And I can always use the wire brush as well, you know. And then just wipe a bit of WD-40 over it and wipe it off afterwards as well. I mean, you can still see it's looking a bit red there. So it's on its feet here, it's not touching the carpet, but I just want to show you can dry clean these. See all this muck here? Just watch this. Comes off. The other thing is, you've got to go in the direction of the traces. I'm covering some of the stuff actually I've filmed already on the 4 slot repair that I've got coming up. So I'll clean up the slots with a bit of deoxit here. They're very clean to start with, to be honest. There's very little coming off this. And I have no problems, you know, with the games at all. So the final steps on this board now. I've been lightly going over these quad flat pack pins. I mean, lightly, super lightly. You might not be able to see there. It looks a little bit oxidised, just a little bit. Yeah, it's hard to see. The other ones were a lot blacker than that. You just went over it once or twice like that, and it went from black to nice shiny metal. You know, and obviously cleaning with the toothbrush and cotton buds and stuff as well, but that didn't really bring the oxidisation off the top. And I'm only being super light there because what I don't want to do is mark the board or damage the pins in any kind of way. But yeah, the other example is here. You might not be able to tell. Looking through the viewfinder, I can't see, but to my eye, I see some a dark surface. To yeah, you might be able to see it better at that angle there. They look a bit dark up here. Let's just see if that makes any difference. Yeah, there you go. I think you can see that. It's only subtle. It's like a layer of soot or something, almost like carbon. Let's see if we can do this side. So I'll try this side now, see if you can see the difference here. Yeah, you can. Just gently on the traces as well, just a little bit. So a quick look at the top side of the board here in the light. You can see it's looking super clean and tidy. There's barely a mark on it really. If it wasn't for the corrosion damage on the top, what's right, chemical wire stuck on it there. Yeah, if it wasn't the corrosion damage up here, and you can see one of the things you get here, I mean, it looks perfect from there. If you get it in the right light, you can see sort of micro scratches and things around where the fiberglass pen has been. Sorry, I know it's on the top of the shot there, it's super hard to see. But yeah, I think overall that has come out pristine. I'm very, very pleased with that. Incidentally, I did swap that cap there. That's a Panasonic. So as per the 4 slot and the 6 slot, this is why these are super desirable, you know, to consoleize. Controller ports, headphone volume, speaker volume. I think you've actually got a headphone out on this one, I'm not sure. I'm going to check that in a minute. But the other thing that makes the 2 slot the most desirable between the 2, 4 and 6 slots is the fact you've got the memory card reader built in here. So a quick look at the chips on here, because this is the first time I've shown a 2 slot on my video. Now bear in mind, like I said, there's different revisions. You can get the newer 2 slot that's got the LSPCA2 and the B1, etc. So you can see this has got the early chipset here, the Pro, is that a C0? Yeah, I think that's a B0. Pro B0, LSPCA0, Pro C0, all 3 chips the same size there physically. You got the shrink dip 68K chip instead of a PLCC that you see on the newer boards. You got everything else is the same. I think you've got the standard Yamaha shrink dip chip here as well. Top left here, we've got the rest of the sound circuitry. Strange how the Yamaha's right across the side of the board. That's a bit crazy to me. But anyway, you've got the Z80 here, the 6116 DRAM for the SRAM for the Z80, the SM1 ROM for the Z80. You've got your Sony CXK 5814s here. This is the fast VRAM for your LSPC. We've got some 43256 here, you know, 62256s effectively, I think. Those are your the slow VRAM. You've got your palettes RAMs here, the elongated ones, Sony CX chips again, 5864s. Your S-Fix ROM, your low ROM, obviously your BIOS, your SP1, and then in terms of RAM, you've got some RAM here and some RAM here. I'm guessing this is the backup RAM, just because it's nearer to the HC32. It might not be, that might be the work RAM. And then you've got the other here, you know, so again, these are marked 43256, but the 62256 or equivalent chips there. I think this has got the same chips we saw in the 6 slot here, the 2803s transistor arrays, aren't they, or some Darlington transistor array packs. And I think those relate to these here, which I think is the credit stuff, and then you've got the illumination thing here, presumably to toggle between, you know, the illumination window for the two different games. Back over to the audio section here, you've got op amp, op amp, op amp, op amp, op amp, main amp, that's your main audio amp, stereo audio amp. I think it's stereo on these. So I think that's most of the main chips covered. You've then got loads of CMOS and TTL chips on here. Well, actually, probably CMOS. There tend to be HC versions of many or most of the chips on these boards. But you've also got an awful lot of these sort of 128 pin, you know, quad flat packs. All over, that one's a bit more than 128 pin actually, all over the board. And this was their first attempt at starting to consolidate some of the logic, you know, taking some of the CMOS logic that was on the, let's say, if you look at a 4 slot, there's an absolute ton. You know, you look at the cartridge board, you know, the top board with the cartridge slots. There's tons and tons of you know, CMOS and TTL chips on there to do with the you know, routing the data depending on which slot you've got selected. In fact, I can show you that here. This is a 4 slot. Look at the logic on there. It's crazy, absolutely crazy. Now that was for 4 slots, but even still, you know, you can have half as much of logic as you've just seen there for 2 slots. So to avoid having, you know, 2 boards and stuff, this is where they start to consolidate. So these, for example, at the top here, relate to the character stuff. I think Neo 257s. These are like a 74 HC257. Well, there's more of them. There's like 4 in each one of them. Which is a 2-to-1 demux, I think. So, you know, you've got 2 inputs and you can select one or the other, you know, i.e. one slot or the other. This is kind of like switching between, you know, the slots there on one of the buses. And then you've got G0s, and from what I understand, I could be wrong, because my memory is not that good, but I think the G0, it was their attempt, it was like a predecessor, looking at the wiki there, it's a predecessor to the Neo Buff. So I think you've got, instead of 2 74 HC245s, you've got 4 of them in there, but there's also an AND gate and an OR gate, and I think they're kind of separate. So, you know, if you've got failures in there, you could bodge, you know, a 245 on there again, or if there's a problem with the AND, you could bodge an AND gate or an OR gate or whatever, or you could find an OR gate or an AND gate spare on one of the other chips somewhere else and use that, route some wires through that, I think. And then you've got Neo E0s, there's a bunch of those, another G0, what's that one, an E0, a 257, I can't remember what the E0s are, but it's going to be a similar thing where they're kind of a standard type of package, you know, where you could, they're interchangeable in certain places, you know, so they've used them in various places on the board here, in different places. Yeah, an E0, 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 that's a Neo I0, a G0, the F0, which I think is related to the dip switches actually, if memory serves. Yeah, so the F0 is one of the things that's kind of been there, well, for the most part. I don't remember there's an F0 on the 4 slot or 6 slot, but the F0 has been around quite a long while. That's one of the sort of chips that you end up with on nearly every board. It may well be on the 4 slot and 6 slot, the ones I've got, that you've got, you know, discrete logic for that. But yeah, nevertheless, they've consolidated a lot of the chips there into these packages moving forward. So this was kind of so I'm guessing these came after the initial 6 slots and 4 slots actually. And the other thing that supports that as well is this is a D0. This is the first time I think the D0 came into use on these boards. So, you know, one of the things like that replaces is the clock stuff. On a 4 slot and a 6 slot, there's a lot of well, number of ICs, 4 or 5 ICs there related to clock generation, and yeah, they merged it into there, despite the 4 slot and the 6 slot having the same, you know, main chipset here. You know, this was an advancement really in terms of using the original chipset, but you know, let's say doing some consolidation into some of these other chips here to reduce the chipset. So of course, if you get a failure in one of these 257s, and this is what I was expecting that this was going to be, you know, corroded, but we might have a fault on one of these, or maybe on one of these G0s. You know, you could do a bodge depending on where it is. I do remember Furtech pointing out on the wiki that in one location you can't just stick a chip on there and fix the individual gate. I'm not entirely sure why. It may well be because there's reliance on, you know, the gates feed into each other or something, I don't know. So you know, you'd have to replicate all 4 things instead of just one, something like that. I don't know. But I think ultimately, Channel Maniac, I forget his name. He's got a YouTube channel. It's a really good channel as well. He does repairs from time to time. But I think he was somebody who contributed some of the pinouts to some of these things as well. Certainly the 257s, I think. So I'll probably get some nail polish just over these exposed traces here. Around here, I might just go very carefully over the traces, but not the voyeurs. And the other thing with nail polish is it's super easy to remove with a bit of acetone. Acetone won't damage the PCB or anything. And afterwards it just looks pristine, you know, it looks like there was never anything there. So yeah, I'm going to continue using nail polish, I think. So just gently cleaning the Jama connector again here. Nice gold plated connectors. I love these boards. And you can see I did just literally just trail a bit of nail polish over there. Left all these vias exposed so I can still do connectivity tests. It's not essential. I could have just left it, and you may argue it looked cleaner as it was. But I just want to make sure that any bits of corrosion that might still remain on here don't start interfering with those really fine exposed areas there, especially where the trace that was not exposed joins the bit that is exposed, if you see what I mean. Because when you try and tin them up, you might cover like 99.9%, and if you look super close to the point where it joins, you know, the bit joins, you might have a tiny particle of copper exposed, and all you need is a bit of corrosion getting onto that, and before you know it, you've got a problem again. In theory, I should do the same thing down here. It's just a couple of connections, so I'm not too worried about that. But yeah, that area there was particularly scary. But as I say, you could just use some nail polish remover on that, and it's back to as it was a minute ago. So there's no big problem with it. It's not a permanent thing. It's not like I've, you know, epoxied something to the board or something. It's like it's not a permanent thing, but it will remain permanent as long as you need it to. It's funny, I've just realised I missed cleaning this whole area here, actually. All around the ROM. Can you see that? All that dirt coming off there. I knew there was one area I'd missed. I always missed something. So for the most part, all the stickers and things remained intact. You can still see the serial number there is at 11214, and I think we've got 3 on the end there. I'm not sure. It's worn off a little bit there. We lost a little orange circle here that was like a quality control thing, I think. It just disintegrated. That was unfortunate. You can see the corrosion started to eat into this silver label here. It's got a U, which, yeah, and there's a U on the ROM, and it says V5, which matches the ROM actually. So yeah, it's version 5 with the BIOS there, and the U indicates US. And this AAMA Protect thing, again, as we saw on the 4 slot, actually, it was the first 4 slot I looked at that I've got in my collection. Yeah, that's the American Arcade Machine Association, I think. This was like a body, you know, an organisation used to, you know, mark boards like this to say, yeah, it's genuine. This is genuine SNK kit. I found that from, I think someone pointed that out on that previous video. Actually, I went away and looked on the wiki. Yeah, that's what that is. Something else I've noticed is this little marks on the end of the pots here. I have gently wiped these pots, actually, you know, just wipe the pads there. Be careful what you use, because, you know, it's kind of like a carbonised, there's a carbon surface there for the wiper arm to slide up and down. Last thing you want to do is wipe all that off. But yeah, gently, I've done that previously. Yeah, so I often forget to test the dip switches. That's something worth mentioning. Do test your dip switches. On the Neo Geo wiki, I'll post a link below, there's a list of what each of them do. But like, for example, if you want to test the RAM on one of these boards and you haven't got a Diagnostics ROM and you're not really sure how to do it, just switch all the switches down like that, switch it on, it'll come up saying work RAM test. But just make sure you switch them all back off, otherwise you won't be able to boot games. And I think there's one here that, I think, is it dip switch 1? If that's on accidentally, it'll stop the system from booting because it disables the CPU. I think it stops it from doing anything. And then there's obviously one for, I don't know, free play, probably, I think. There might not be a free play one. I honestly can't remember what they do. I've never really needed to use them for anything. But yeah, do test your dip switches when you're servicing one of these, because you never know, you might have a problem with one of them. Well, I nearly forgot, but I didn't. I'm going to scratch around here and add a little bit of solder just to ground the crystal properly. I mean, it's got a strap there, you can see, but and this one's fairly tight, so this doesn't actually need doing, but you know what, you want a physical connection with a ground like that. You don't just want something just, you know, manually holding against it and hoping for the best. At some point that crystal could come loose there and you get a bit of jitter. And they're using solder containing flux anyway. There's a hair on the end of the iron there, I just spotted. I really should let the iron warm up a bit more actually, because you need an incredible amount of heat to do something like that. But we just want a small blob of solder, there we go, joining the can to the strap. And try and you know, stick your solder where you're not going over the crystal print there, so you can see what speed it is. That's something I always forget to mention. I think most of the time I usually manage that without an issue. But you don't want to overheat those. I mentioned you need a fair bit of heat, yeah, but don't overheat them, because crystals break from thermal stress, you know, they expand and crack. I've marked it up to say I've fixed it 2019, yeah, 2 being the perfect number. Yeah, so I need to remove this foam on the underside here now actually, and can you see you've got some damage here? It's like a screwdriver or something's gone across there on the underside, something metallic, but the traces are okay. That was one of the things I noticed when I worked on this early on. I thought, I wonder if that's got a relationship to the ZMC problem, but I tested connectivity and I couldn't find an issue, so just need a little bit of nail polish just over those bits that are scratched, I think. And there we go, as a quick look at the underside. This is the area with the battery, so you can see the work I did around the components there. It looks pretty clean. There's the bit of nail polish added with the where the traces were scratched, and we got rid of all that black foam and stuff. So yeah, looking pristine. So finally I can get it back in its shell. The easy way to do this is to do it upside down actually. There's a bit of dirt there I just spotted, I'll clean that off in a sec. Yeah, and just loosely screw the feet on from this side. Then you can flip it over and tighten them up, you know, and I'll angle these underneath like that, and that angle. All reassembled. I've wiped this down with some WD-40, you know. There are some little bits of redness on it, but it's smooth, so yeah, I don't want to interfere with that further. I think that'll be okay, as long as that's stored okay and it's not in a damp environment, it should be fine. And as you can see, the slots are pristine on this one actually. They have hardly seen any use at all, those. So I've got it all connected up there. I've got Kraut Busters, which arrived recently, and Samurai Showdown. I'll just let that cycle through the demos. Let's try Kraut Busters on its own. I didn't know it worked because I played it on here last night. Yeah, that's booting now. So apologies for light glare there, but yeah, hopefully you can see us working. Fantastic. And just to show you, can you hear the sound coming through the headphones here? Yeah, so the 3.5mm connector at the front there, the socket at the front, that's headphone out. So it's sweet being able to listen to headphones easily on one of these. Yeah, so super annoying we had to sacrifice a ZMC2 effectively. I prefer it when it's off the shelf parts, but you know, this is that MV1AX board. You can see, you know, I cleaned up all the pads and everything. This, you know, could could be made to work again if you were, you know, if you found a load of Neo buffs and the ROMs, the various ROMs that are faulty on here, and then you reinstated, you know, the IO, and we got a D0 and you know, numerous other things. I've still got the PALs for this, I think. I've still got the one or two of the chips to go back on here, but yeah, the ZMC came off this in a previous video actually as part of another repair, and I just never put it back on. I thought, keep it off because now we know it works. And yeah, it saved this one. The other plus with this pickup was it came with this wiring loom here. I'm not really sure what to do with it. I mean, is this an official SNK wiring loom? It probably is. If you look at these connectors here, someone might recognise those and go, yeah, that's out of an official cab. It's worth keeping, I guess, just for the connector here, but someone's sliced it, can you see here? Quite why you would do that, I don't know. Slice some of the connections and not others. Anyway, I do hope you found that interesting. Thanks for watching, and I'll see you soon.